Welcome to section 3.3. So we're going over applications for systems. Now, what are the steps for solving application problems? So the first thing you want to do is to make sure to read the problem carefully. And what you're going to do is to look for the unknowns. Okay, oftentimes that would have to do with what the question states. Second thing you're going to want to do is to organize your information. So organize the given info by the units. Oftentimes, organizing by units is probably the best thing to do. So organize the given info, and I would say by units is probably the best way. Okay, then you're going to create a let statement for your variables. And then after that, the next thing you're going to do is to create your equations. So let's say if you have two variables, you're going to need to have two equations. Another way to look at that is the number of variables you have should equal the number of equations you're going to end up with. So for step 4, you're going to create the equations, and once again, I would do that by units. And then step 5, what are you going to do? Well, you're going to solve. And lastly, step 6, answer according to the problem. Okay, these steps are a little different than the steps on page 254, but these are the steps that I use for solving. Alright, so example 1. A rectangular soccer field has a perimeter of 360 yards. Its length is 20 yards more than its width. What are its dimensions? So, first off, actually, I'm going to go ahead and draw a diagram to get a better idea on what this looks like. So we have a rectangular. The reason I thought of drawing a diagram is because they brought up a shape. Okay, so a rectangular has a perimeter of 360 yards, length is 20 yards more than its width. And we want to know what the dimensions are. So we don't know what the dimensions are, so I'm going to go ahead and say, well, let's say let W equal width, and let L equal the length. So we know that this is W, and this is L. So now we need to create two equations because we have two variables. Let's go ahead and set up our system. So what are we given? Well, we're told about the perimeter, right? That's one thing we can figure out, is we know that all of these sides added up together should give me 360. Well, that means 2 of the widths, so this side and this side, plus 2 of the lengths, this side and this side, should end up equaling 360. What else do we know? Well, we know that the length is 20 yards more than the width. So the length is supposed to equal 20 yards plus the width. Alright, and there's our other equation. So L equals 20 plus W. And there we have our system. So this was written in terms of the perimeter, and that was in terms of relating the widths. The width and the length. Doesn't always stick by units, which is once again why I said it's helpful. Doesn't always work, but that's a good way to do it. Alright, so let's go ahead and solve this. This is just a 2 by 2. So to solve, I am going to use, I guess I'll use substitution since it's set up perfectly for substitution. So know that L equals 20 plus W, so I'll go ahead and plug that in. So 20W plus 2 times 20 plus W equals 360. And 2W plus 40 plus 2W equals 360. Adding the W's together, we'll get 4W plus 40 equals 360. Let's go ahead and subtract the 40 from both sides. So 320. And dividing everything by 4. Let's see. Well, we know that 4 can go into 32 8 times. So that'll be, let's see, 80 left over. Alright, so we found 80. But now we need to find, so we found W, we need to find L. How will I do that? Well, I'm going to go ahead and write finding L, because I have a lot of work going on, and I'll use this equation here because it's already solved for L. So L is going to equal 20 plus W, and we know that W equals 80. Go ahead and replace the W with 80. We get L equals 20 plus 80, so L equals 100. Are we done? No, because this is a word problem, so we need to answer in word form. So what would the answer be? The dimensions are 100 by 80 what? Yards. Period. And we're done. Let's take a look at example 2. June is a transfer student to UH Manoa for a semester and wants to play badminton at the Honolulu Badminton Club. There are 2 options for playing. Option 1, he could pay $13 each time he plays, or option 2, he could spend $25 on a membership and only spend $100 each time he plays. Create a system of linear equations that represents the 2 gym membership options in terms of cost per number of visits. Be sure to include a let statement. Alright, so we just want to figure out 2 equations. And what are we looking at here? Talking about memberships. So option 1, it's $13 each time he plays, and that's it. Or option 2, he spends a flat $25 on a membership and then spends $10 each time he plays. And what do we want? We want the cost per number of visits. So let's go ahead and say, let C equal the cost, and let's let V equal visits. Actually, you know what? V is kind of hard to write. So I'm going to go ahead and let's use a T for visits. Alright, so the 2 equations. Well, the first gym membership, that would be the cost is going to equal 13 each time he plays. So if he goes once, that's $13. But he goes twice, that's 2 times 13. So it's basically 13 times the number of times he goes, which would be 13t. So C equals 13t. In option 2, he can spend $25 and only spend $10 each time he plays. So this time the cost is going to equal, let's see, $25 flat for one time. So $25 plus $10 each time he visits. So that would be 10 times t, because each time he goes, he spends $10. And there we have our system. Alright, so B, after how many visits would it be a better deal for June to get the membership? So this is going to be a little different than other systems. What we're going to do is we're going to equate these. We want to figure out when this equation would be better than this equation, which means we want to figure out when 25 plus 10t is going to be less amount of money, so less cost, than 13t. I want to figure out when this cost will be less than this cost. Let's go ahead and solve. So minus 10t, minus 10t, 25 less than, so that'll be 3t. We can divide both sides by 3. Alright, 3 can go to 25 8 times, and then there's going to be 1 left over, so it'll be 8 1/3 less than t. So, remember, t is talking about the number of visits. So, if t is greater than, we can't say 8 because this is technically greater than 8. So we'll say after 9 visits, what do we know? It will be better to get the membership. Period. Alright, let's take a look at the next part. If June is on Oahu for a 16-week semester and plans to play once a week, which option is better? Okay, so let's just think through this one. So, 16 weeks and he plans to play once a week. So that means he plans to play at least 16 times. So he plans to play 16 times. We know it's cheaper to have the membership if what? If he plays 9 times, 9 visits. If he plays... So what do we then know? So So it's better that he gets the membership. All right, now this is the type of reasoning that I would look for in an answer like this. You state what he's looking for, then you state what we already know from above, and then you state your final opinion. All right. Let's take a look at example 3. A train travels 600 miles in the same time that a truck travels 550 miles. Find the rate of each vehicle if the average train rate is 5 miles per hour faster than that of the truck. This is a distance problem, a motion problem, right? So because of it being a motion problem, I'm going to go ahead and set up a chart for a motion problem. We know that distance equals rate times time. This is in general for motion problems. So since we're talking about two different objects, I'm going to go ahead and set this up for two different objects. We have a train and we have a truck. All right. And what do we know? Well, we know the train travels 600 miles in the same time that a truck travels 550 miles. So the distance 600, 550. And we want to find the rate of each vehicle if the train's average rate is 5 miles per hour faster than that of the truck. So what is our variable? What's the thing we don't know? And that is the rate of each vehicle. So I'm going to go ahead and say let's see, x equal rate of the train, and y equal rate of the truck. All right, so what do we know? Well, for train, we know that the rate is x and the truck is y. How do we know that? Well, we picked that out. So what else do we know? Do we know the time? We don't know the time. So the time, if I use the equation for distance equals rate times time, time is equal to, well, let's divide both sides by r. Time is equal to distance divided by rate. Well, so that'll be 600 divided by the rate, which is x. And for the next one, it'll be 500 divided by y. 550 divided by y. So these are our two times. And what do we know about the times? Well, they travel the distance in the same time. So the time values should be the same. Let's go ahead and equate them. So 600 divided by x is equal to 550 divided by y. The times are the same. Okay, we've created one equation, but we still need two because we have two variables. Is there anything else that relates these values together? Well, we know that the train's average is 5 miles per hour than that of the truck. So the train is faster than the truck, which means that the rate of the train, which remember we said was x, is 5 miles more than y, which is the rate of the truck. So 5 plus y. And there we have two equations. One was in terms of time. Oops, it's supposed to be a T-I-M-E. One was in terms of time, and the other one was in terms of the rate. So this is where it's easier to create the equations if you're looking at the time variables and then at the rate variables. So let's go ahead and solve. I am going to use substitution because this is set up for substitution. Let's go ahead and I'll substitute x is equal to y plus 5. So 600 divided by y plus 5 equals 550 divided by y. Well, since this is an equation and I have two fractions equal to each other, I'll use the cross multiplication property. And I can use this when I have two equations equal to each other, two fractions equal to each other. One fraction, two fraction. All right, so multiplying, I have the 550 times the y plus 5 equals the 600 times y. All right, let's go ahead and distribute that 550 in. We get 550y plus 5 times 550 equals 600y. All right, solving for y, we'll go ahead, subtract the 550 from both sides. And we have 5 times the 550. I'm not going to multiply that out just yet. So 600 minus 550, that's just going to be 50y. Let's divide both sides by 50. And what do I know about this? Well, let's see. 5 can go into 50. That'll be 10 times. And then 10 and 550, we can cancel out those zeros there. And we're just left with 55. So I didn't need to use a calculator. All right. And that's y. So we need to find x. So how do we find x? Well, let's use this equation right here. X is going to equal y plus 5. X equals, what did y equal? Y was 55. So that'd be 55 plus 5, which is 60. Are we done? Nope, we need to answer in a sentence. So x was the rate of the train and y was the rate of the truck. So the rate of the train was 60 miles per hour. Remember to use our units. And the rate of the truck was 55 miles per hour, period. All right, let's take a look at the next example. Example 4. Keiko has a boba tea business that she runs at the Enchanted Lakes Farmers Market on Sundays. She sells a small for $3, a medium for $4, a large for $5, and last Sunday she sold a total of 29 drinks and made $105. She sold twice as many smalls as mediums. How many of each drink did she sell? All right, so what do we know here? We have the question of how many of each did she sell. So how many variables do we have? Well, she sells 3 drinks, so we're talking about 3 variables. So I'm going to let x equal number of smalls, small drinks, y equal, that's a number of large drinks, and z equal number of, y is going to be number of medium, and we'll let z be the number of large. All right, so now let's go ahead. Since we have 3 variables, we need 3 equations. What is our word problem talking about? Let's see. We know the total number of drinks. That's one bit of information. Total number. What else do we know? We know the dollar amount. So that's a different unit. The total number and then the dollar amount are both different. And we also know another piece of information. She sold twice as many smalls as mediums. So from this, I think I can create my 3 separate equations. The total number of drinks was 29, which means x plus y plus z should equal 29. Okay, we have one equation down. Next, we know the dollar amount. The total amount of money she made was $105. So, if she sells a small for $3, a medium for $4, and a large for $5, the total number of all of those should equal 105. So 3 times the number of small she sells plus 4 times the number of mediums plus 5 times the number of larges should end up equaling 105. And lastly, she sold twice as many smalls as mediums. So the number of smalls is 2 times the number of mediums. Okay, so small is equal to 2 times the number of mediums. And there we go, we have our system. 3 variables, 3 equations. So for solving, remember the first step we do is we pair them off. However, if you'll notice here, this one already has 2 variables. So I'm going to give this one a pass. It'll go and join in my 2 variable system that I do next. So I'm going to pair off these 2 and get rid of, well, which variable is this one missing? This one's missing z. So I'm going to get rid of z on that pairing. So let's go ahead and do that. Cancel z. So I have x plus y plus z equals 29. 3x plus 4y plus 5z equals 105. Now in order to cancel the z's, I need to match them. So since the other one's a 5z, I'll go ahead and multiply everyone in the top by 5. So 29 times 5, let's see that. I'm going to do that on the side. Scratch work. 29 times 5. That'll be 45. 10 and 14. 145. Alright, so in order to cancel the 5z's, we're going to do subtraction. And then what do we have? We have 5x minus 3x, so that's 2x. 5y minus 4y, so that's y. 5z minus 5z, cancels right there. 145 minus 105, just going to be 40. Ha, so now we have our equation in two variables, so we'll go ahead and bring this one down and pair these two off. So let's see the new pair for the 2 by 2 system. We have x equals 2y and 2x plus y equals 40. Now this looks like it's perfectly set up for substitution, so I'm going to go ahead and do that. I'll sub x equal to 2y, because I know x is equal to 2y. I'll sub that into this equation here and solve. So 2 times 2y equals y equals 40. Oops, sorry, plus y equals 40. So then 2 times 4y, that's going to be 4y equals 40. And we have 5y equals 40. Dividing both sides by 5, we get that y is equal to 8. Almost done. We need to find the other two. So we know y is equal to 8. So let's go ahead and use this equation here to solve for x. How come I wouldn't use one of these? Well, we only know one variable. Okay, so we need to go with what we have. Let's go ahead and say finding x. So we'll use x equals 2y. And I know that y is equal to 8. So I'll go ahead and plug that in. X equals 2 times 8, and we get that x is equal to 16. We have one more variable to find, and that is z. So I'll go ahead and write finding z. Keep things neat. And I'm going to use this equation up here because it's the easiest one. X plus y plus z equals 29. What do I mean by the easiest? Once again, it just has the simplest numbers. We can't use this one because it doesn't have z in it. So we knew that y is equal to 8. So we're going to substitute y for 8. And x is 16. And we're solving for z. So we have 16 plus 8 plus z equals 29. 16 plus 8 is going to be 24. Subtracting 24 from both sides, we get that z equals 5. All right, we're not done yet, though. How should we answer? Well, this is a word problem. They're wondering how many of each drink she sold. So my answer is going to be, she sold, let's see, we had x was the smalls, 16 smalls, 8 mediums, and 5 larges. Period. Alrighty, and that is that for this section. If you have any questions, please come by my office hour or send me an email.